My name is Paula Hollywood, and I am a senior analyst at ARC, and I work on the asset lifecycle management team as well as the industrial Internet of Things team. And this session is going to talk about minimizing safety risks with asset performance management. It is possible to do, and I hope our speakers and panelists today will help convince you of that if you're not convinced already. So I'd like to start today with reminding you of some of the more recent, truly severe industrial accidents that caught everyone's attention. There was a picture of that train accident up there in Canada for you Canadians. I'm not sure where it went, but that was our latest one. But just a reminder, really, of why minimizing safety risks is important. So this data is actually from the U.S. Labor Statistics Bureau in 2015. And it represents the number of fatal U.S. work injuries from 1992 to 2014, which is the last year that they had data. What I think is interesting here is that there was a slight uptick in 2014, and that was actually by 2%. And what that's actually attributable to, I'm not really sure. But what I do think is truly interesting is that if you look at, say, 2005, we kind of reached a new low peak, if you will. And then ever since then, we've been on a decline, at least until about 2010. And what caught me was that in 2005 is when Buncefield happened. So I'm wondering if we put some safety measures in place that help to reduce those workplace injuries in that part of time. But it appears that ever since then, it's virtually leveled off. So my question would be, is this the best we can do, or can we do any better? I maintain that we can do better. And it isn't just deaths, it's injuries, workplace injuries as well. This data is from Liberty Mutual. And just look at the staggering costs of what disabled workplace injuries is. $62 billion nearly. That's phenomenal. And to me, I would think the costs alone would be enough to drive improvement. I don't know if you would share that same opinion, but it's pretty eye-opening to me. So what are the sources of plant incidents? According to Marsh McLennan, the greatest source of plant incidents is operational error. Interesting. Also interesting to note that mechanical failure, process upsets, and design errors are not that far behind. But I would maintain that those last three are easier to control than the operators, because human behavior is the hardest to control. But hopefully, if our people are properly trained, they'll rely on their training should something happen, and that will kick in, just like a police officer or a soldier or something. Whatever their training is will kick in when the time comes. But it is the biggest variable. The humans are the biggest variable. So what are some of the factors contributing to operational risk? They are operating our plants closer to the limits, where a lot of our accidents happen in the transient operational state. We are using hazardous waste or hazardous raw materials in our production processes, or the product of our processes in any case. We manufacture hazardous intermediates. We've got untrained personnel out there, and we've got a lot of aging physical assets. Human assets too, mind you, but aging physical assets. And our goal really is to protect the people and equipment while making the most effective use of each. And risk is not always bad, you know. We can use risk to identify opportunities, and we should take advantage of those when it's possible to do so. So to my mind, Reliability and safety go together like a hand in a glove. A reliable plant is a safer plant. It also contributes to quality, better quality, cost effectiveness, and environmentally sound policies. Think about the airline industry. Aren't they thinking safety first? Are you going to get on an airplane that's not safe or fly with an airline that has a poor safety record? I think you're going to avoid them. I don't want to cast the aspersions here, but I'm wondering if Malaysia Airlines is having some problems. I think they may be. Companies profess that safety is a top priority, but very few cite reliability as a top priority. But I believe that that's changing. And I think that we've heard that here at the conference over and over, even in the executive panel discussion yesterday. What did they say was most important? Reliability. So I think that will change, or it is slowly changing. But the thing is, safety is dictated by law, reliability is not. But the data is compelling. Again, reliable plant is a safer plant. But at least for now, participation is voluntary. I don't believe that's going to be the case forever. In the not too distant future, I believe there will be some outside forces exerting influence on our industry that will change that. And I mean that primarily from the insurance industry. They're going to be looking to learn how you're protecting your plants and how you're mitigating your risks as a condition of providing you insurance. And that's going to happen. It's not a question of when, of if, excuse me, it's going to be when. So what are the characteristics of reliability? Poorly designed. Poor design is a characteristic of reliability problems. The technology is inadequate for the application of the environment. We have manufacturing faults, errors, as well as poor maintenance. Safety problems can be characterized by unintended harmful incidents and accidents. They're traceable to shortcomings in concept and design. But it applies to process and personal safety. So we're not just talking about the processes, we're talking about the people too. I like to talk about the people aspect related to safety because engineers don't like to talk about that because it's not hard data related, it's kind of warm and fuzzies, and they like data. I like the softer things, if you will. So this brings us to ARC's reliability model. What we're trying to portray here, what we've distilled this down to, is that we believe that it's costs and risks that are hanging that we are weighing, and safety and the benefits are in the balance. So what is a safety culture? Well, the UK Health and Safety Commission defines it as the product of individual or group values, attitudes, perceptions, competencies, and patterns of behavior that determine the commitment to and the style and proficiency of an organization's health and safety management. They're taking this very seriously, and the reason that they are is that they believe that business benefits can be derived from safety practices. And I believe that that's true. I think you probably do too, or you wouldn't be here. So what are some safety best practices? Safety is an operational strategy. It has clear management, visibility, and leadership. Ownership of safety is by all the employees. It's at every level of the organization is accountable. We have knowledge about it and share information freely. The roles and responsibilities are clearly defined and communicated. It's measured by objective and quantifiable terms, and it's integrated in all facilities, operations, and processes. And it's guided by a safety committee, a broad-based one, so that we can cover all of the eventualities. So what is a reliability culture? Reliability culture is one that's focused on preventing failures. So we ensure that our assets are reliable and available when we need them. Essentially, we have high uptime. We have assets are functioning and producing product as designed. Maintenance and operational costs are at a reasonable level, and plant assets are generally in a safe operational state. We don't experience too many excursions. But the challenges to achieving a reliability culture is the availability of quality information, work process documentation and understanding. Are we really getting that across? Does the individual really understand his role and responsibility? Do we have processes in place that we need to adhere to, creating that discipline, that mindset? Are we continually improving the skills of the workforce? And we need to increase the capacity for decreasing the resistance to change. You know, we have a lot of guys out there that still like to be rewarded for fighting the fires. Hey, that pump is acting up again. Let's call so-and-so in from his weekend and get it fixed. So he goes in and he's the hero, and isn't he great? And he gets a lot of overtime for that. So he's probably not doing a whole lot to discourage that unless it's really interrupting his quality of life. And then he might jump up and scream, and I'm not doing this anymore. But I'm guessing he probably likes the money. So what are some reliability best practices? Well, we want to measure the right things. We want our KPIs to be clearly defined. We want to be sure that the knowledge is captured. We make training a priority. We want to be sure that our assets are prioritized according to criticality. If everything is important, then nothing at all is important. So we need to understand what is our priorities, and that helps us do that. We practice root cause analysis on a wide basis. We determine what the source of our problems are, and we fix them. Both production and maintenance take ownership of this, as well as it really is the responsibility of everyone in the plant, just as safety is. I don't want to minimize that at all. Operators and maintenance departments are allowed to practice and given the tools to practice preventive or predictive maintenance. And the key data that's collected and analyzed to determine asset health are being measured and measured properly. Those are the KPIs like mean time between failure and mean time to repair. But they have to be meaningful to your organization. That's the key. So there are some synergies between these two. And I believe that they both require commitments from the highest levels in the enterprise. Safety and reliability become integral components of our daily activities. An enterprise should appoint a champion who assumes responsibility and has decision-making authority. It's nothing worse than being handed some responsibility and not any authority to make that happen. I think perhaps we've all experienced that in our working careers. It's a no-win situation. The roles and responsibilities are clearly defined and understood. We conduct periodic audits and make adjustments accordingly. We apply root cause analysis to incidents and failures. Training is ongoing. We have measurable metrics and meaningful metrics. And most importantly, we have open lines of communication. But it isn't just the soft, fuzzy stuff where APM comes in here, because we can use APM to ensure the reliability of our safety systems, of the various safety systems, whether it's the SIF, SIS, SIL, all of those can be helped. What we use this for is to help us provide a proactive view of risk so that we can ensure that the failure rates actually comply with design. We detect hazards in our processes. We facilitate the safe state, all of those kinds of things. And what I thought was really interesting was that I found a statistic someplace that said that 44% of SIS and SIF related errors occur during the hazards assessment specification phase of the life cycle. That means we're not designing them properly. So I think, if you wait a minute, I'll show you how we're going to change that. And I also think that, certainly as technology continues to expand, but it will create vulnerabilities too from a cybersecurity perspective, is my fear. So we need these layers of protection, and that's actually what the APM solution can do, help you ensure these layers of protection. Because if you think about it in your own personal life. And a lot of these accident reports on these major industrial accidents conclude that it's not one incident that happens. It's a series of events that just line up, just like that Swiss cheese model that you see here, and it gets through the hole, and it doesn't get caught. And that's when we have an incident of severe consequences, or with severe consequences. So we can use APM, I believe, more effectively to help ensure safety. Because our goal really is to design for reliability. This is ARC's asset lifecycle management model. And you've probably, if you've come to our events here over the last few years, you've probably seen this many times. But we break this down into the design and build phase over in the upper left, which is project performance management. We hand over the data to the owner-operator, who is now responsible for operating and maintaining that equipment over its life cycle. And in this particular asset, APM space, O&M space, we're talking about EAM, APM, PM, we're talking about reliability, as well as environmental health and safety solutions. So what we're really trying to represent here is that we take these lessons learned over here, and we build upon that knowledge that we use in these phases, so that when we make modifications or we design new facilities, all of this information gets fed back into the new design, so that we actually design reliability into the product, bake it in, or into the system, as opposed to trying to modify it out later. So, in closing, before I introduce our first speaker, I'd just like to caution you that don't underestimate the value of culture. Culture eats strategy for breakfast and technology for lunch, so don't let it get the better of you, because it really can. I'm sure you've had that experience.